Hello everyone, this is inbarin with a main channel video. In this video I will explain my strategy for the Codingame 2024 Winter Challenge. I will also show some code snippets but not everything. To be honest, I never expected to join this challenge and totally didn't expect to be making this video, but here I am anyway. And also I'm going to assume that you passed the Wood League and know how the game is played and want to get better. Ready? Good. Not ready? I'm going to start anyway. Number 0. Before you ever start the game, you should create yourself an interface to work with, otherwise you will be very sad in the future when trying to make changes. This means your main function better look something like this, which I'm currently showing on screen. While I could theoretically move this logic to some function and call it doTurn, I didn't see the reason to bother with it. Obviously, even this function has some room for improvement. For example, parent organ detection could be useful, but that requires me to put in more effort, so I currently didn't make that. As you can see, for example, I have a function to get all the entities, and it makes it easier to think about other parts of the logic. After that, I have a stock class. The class simply holds information of resources, but it provides a layer of abstraction, which makes it again easier to think about it. And my entity class is putting in work. I've created functions like isProtein or isEnemy as another layer of abstraction. Number 1. Your code should be modular. It would be simpler to understand and easier to improve. Your modules are up to you, and you should decide what modules to write by yourself. I'm going to give an example of what modules I'm using, but this is just an example and you can create different modules for yourself. Module 1 is to attack the enemy when you can deal damage. After that there's the defend module, and I'll explain it later. To finish off the attacking and the combat modules, there's also the predict module, which predicts enemy attacks. Next, there's the harvest module to harvest new proteins and improve the income. Then the hunger module for when you are missing proteins. Move A towards the enemy and move B towards proteins. After that I have some default logic in case all modules fail. Number 2. How should your default logic look like? You reach your default logic after all your modules have failed. In my case, it means you cannot attack the enemy, harvest proteins, or even move towards new proteins. That means you need to just grow randomly and take up space. My idea is just to go over all your organs and all directions, and if an organ can grow in any direction, give it an action. Number 3. My combat modules attack, defend, and predict. This is based on the first win condition, which is if you eradicate your enemy off the map. To do this, you should grow tentacle organs that attack the enemy. However, you should remember that most of the times, when you can damage the enemy can also grow to where you could damage them and damage you instead. That is, unless you grow into a tentacle. That is not allowed. This means it is urgent to grow where the enemy can grow, otherwise you risk them attacking you. Next is the concept of defending, where you grow a tentacle that was at a distance of 2 empty spaces, which leaves the opponent vulnerable to an attack if they didn't also defend. Finally, predict is for a distance of 3 empty spaces. If you predict the enemy will go towards you and they go towards you without a tentacle, you win. And lucky for me, there are only so many directions on a grid, making enumeration over even 4 moves possible. For example, this function, which I call grow to enemy number 2, is my defend module. Again, I have other infrastructure functions like canSpend that reduce the amount of energy it takes me to build such modules. Number 4. Move A and move B. Your second win condition is that the game ends and you have more organs than your opponent, meaning you take more space on the map. For that, I made a function that does graph traversal to find the shortest way from a list of points to another list of points. With such a cool function, I could also use it over proteins as targets and not just the enemies. And finally, let's return to the default logic and explain it better. When you reach the default logic, nothing worked. Nothing at all. You can't move towards the enemy, you can't move towards proteins, and basically, you can't do anything. That means it's time for you to grow randomly anywhere at all. Good luck with the rest of the challenge. I shall probably get back to some improvements. And that's it. This code, that I obviously removed some of the lower level details, is currently, as of the new year, at the top 3% of players. This means rank 108 out of 3600. I will leave this video with a few of the last battles to show you.